The universe is a vast cathedral of silence. Stars shimmer like distant candles in a cathedral, too immense for our comprehension, and planets drift in solemn, tireless arcs. Among this eternal calm, Mars hangs in the distance, a rusty sentinel in the black, watched by telescopes and orbiters alike. Its surface bears the marks of millennia craters, valleys, and the faint, mysterious traces of wind-blown dust. Yet no, our red neighbor is about to witness a visitor from beyond, a silent intruder that has captured the attention of astronomers and dreamers alike. 3I Atlas. The name alone carries weight, a blend of numerical precision and mythic resonance. Initially, it was just a point of light, a faint signature in the ever-scanning instruments of Earth's observatories. But as the data streamed in, patterns emerged that defied the ordinary. Its trajectory was not merely a path dictated by gravity and inertia. Subtle deviations suggested influences unseen, subtle forces at play. Even as it approached the Martian sphere of influence, the readings hinted at behavior that conventional physics struggled to explain. Astronomers checked and rechecked their observations. Could it be an error, a glitch in the sensor arrays, or a miscalculation in orbital models? Every anomaly was scrutinized, every number verified. And yet, the conclusions remained. Atlas moved differently than any comet or asteroid we had previously encountered. Its acceleration, its reflective properties, the slight tremor of its course, as measured against distant stars, all of it suggested something more than a mundane interstellar visitor. Imagine a spacecraft drifting silently toward a city you've long watched from afar, a shadow passing beneath streetlights unnoticed until it grows into awareness. That is the sensation that 3I Atlas imparts. It is not loud. It does not announce itself with fireworks or noise. It simply exists, a presence recorded in photons and radio waves, interpreted through our instruments and imagination. And in that quiet approach, a question arises, one that humankind has whispered for centuries whenever something extraordinary appears in the sky. What is it, and why is it here? The data that accompanies Atlas' approach is as meticulous as it is perplexing. Spectral analysis shows a surface composition unusual for known comets. A hint of metallic elements, a density that fluctuates slightly under gravitational modeling. Swarms of fragments, trailing behind it like a faint echo, have been detected, each too small to resolve visually, yet unmistakable in their influence on light and gravitational pull. Every new observation adds layers of mystery. Is this natural fragmentation, a leftover from a distant stellar collision? Or is there something more, a pattern, a design hidden in what appears chaotic? From Earth, astronomers chart its progress with a mixture of awe and unease. Every orbital calculation, every photometric reading, every radio signal captured contributes to a slowly unfolding story. Atlas is not just passing by, it is becoming part of our collective imagination, a symbol of the unknown pressing gently against the boundaries of human understanding. Its path toward Mars adds another layer of intrigue. The red planet has always inspired fascination, speculation, and mythology. To witness an interstellar visitor approach Mars is to feel history converging with the present, science intertwining with wonder. And yet, for all our instruments and models, there is a human impulse that lingers at the edges of observation. We name what we do not understand. We chart what frightens or fascinates us. The act of observation itself carries with it a subtle sense of invitation, an acknowledgement that to watch is to participate. In this sense, Atlas is more than a celestial object. It is a mirror held up to our own curiosity, a reminder of how profoundly fragile and yet resolutely inquisitive we are. As the distance between Mars and Atlas decreases, the tension grows. What will happen when these two bodies, one ancient and solitary, the other silent yet enigmatic, draw near? Will Atlas continue its journey unperturbed, a wanderer merely passing through our cosmic neighborhood? Or will the closeness of Mars reveal features previously hidden, behaviors that defy our expectations even further? The answers are not yet known, and in that unknown lies the pulse of the narrative, the silent intrigue that propels us forward, gaze fixed on a point of light, moving inexorably through the dark. In this first chapter, we have seen the outline of a story that is only beginning to unfold. Atlas approaches Mars with quiet inevitability, its presence recorded in meticulous data and careful observation. The swarm of fragments trailing it adds subtle tension, hinting that what we witness may be more than a solitary wanderer. And while the universe offers no explanation yet, the act of watching, measuring, and wondering draws us into its rhythm. The silent intruder does not speak, it does not announce itself. Yet in its quiet passage, it whispers to us the possibilities of what might be, what could happen, and what remains beyond human control. As Mars watches in silence, as telescopes turn and instruments hum in calibration, we are reminded of the precarious intimacy of existence. A small planet, a distant intruder, and the infinite stretches of space that separate certainty from awe. And so, we begin not with answers, but with questions. The story of 3IATLAS is unfolding, and we are both witnesses and participants in its quiet, impossible journey. The cosmos is patient, and so must we be, watching the intruder move through the void, silent yet undeniably present, as our red neighbor waits to receive it. Mars has always been more than a planet. It is a mirror, a stage, and a question that humanity has never stopped asking. For centuries, we have looked toward that crimson light in the night sky, tracing its erratic dance across the constellations. The ancients saw in it the spirit of war, a fiery god whose presence foretold conflict. To others, it was a restless wanderer, its blood-red hue a reminder of passion, mortality, and change. Mars has always been both familiar and foreign, close enough to be seen with the naked eye, yet distant enough to hold its mysteries close. Our telescopes turned toward it as soon as glass could magnify the heavens. In the 19th century, the Italian astronomer Giovanni Schiaparelli sketched networks of channels canali that some mistranslated as canals. Almost overnight, the public imagination ignited. Were these the marks of civilization? Did intelligent life thrive on Mars, digging vast waterways to sustain a fading world? The American astronomer Percival Lowell staked his career on the idea, mapping elaborate canal systems. Seeing in the wavering light of his telescope a world in decline, a civilization struggling against time. Even as science later dismissed these illusions, the story had already taken root. Mars became a symbol of both hope and dread, a canvas for our fears of cosmic loneliness and our dreams of finding kin among the stars. Through the 20th century, Mars stepped from myth into science. Probes like Mariner, Viking, and eventually the rover's Spirit, Opportunity, Curiosity, and Perseverance revealed a world at once desolate and alive with history. Dry riverbeds hinted at flowing water long ago. Sedimentary layers told of climates that shifted and seas that once may have spread across its surface. Even methane readings, flickering inconsistently in the atmosphere, whispered of the possibility, however faint, that Mars may not be entirely barren. To study Mars is to see echoes of Earth's own story, written in a colder, dustier language. And so, we have watched. Mars is the most observed planet beyond our own, a neighbor so familiar that we can track its weather in real time. We know when its skies fill with dust storms that shroud its entire globe. We monitor its thin atmosphere, its shifting ice caps, the changing dunes sculpted by Martian winds. Our satellites orbiting Mars beam back terabytes of data every year. If there is a second world we know intimately beyond our fragile Earth, it is Mars, which is why the approach of 3I Atlas feels so uncanny. To imagine a visitor from interstellar space drifting into Mars, domain is to feel a collision of narratives. the most studied world in our solar system, and the most mysterious object ever to pass through it. Atlas is not a comet we predicted decades ago, not an asteroid tracked for years. It came suddenly, quietly, its trajectory only recently understood. Now, it is threading toward the very planet that has so long occupied our imagination. The scientific mind sees this as opportunity, an unparalleled chance to observe an interstellar object as it interacts with the planet's gravity, atmosphere, and magnetic field. Already, mission teams prepare to reorient orbiters, to sharpen instruments, to watch the meeting with clinical precision. Every shift in light, every tug of gravity will be recorded, analyzed, modeled. For planetary science, this is history in the making. And yet, beyond the science, there lingers an unease. Mars has always been the stage for our cosmic projections. What does it mean, then, that this visitor comes so close to it? Myths once spoke of omens in the skies, of red stars heralding war or transformation. Today, we frame our anxieties in data and probabilities, but the emotional weight remains. Atlas is not just approaching a planet, it is approaching a symbol. A world that has, for as long as we have watched it, embodied our own questions of survival and destiny. Imagine the moment, a silent fragment from the abyss of interstellar space drifting across the orbit of Mars, passing over valleys carved by water, long vanished, moving above mountains taller than any on Earth, skimming past the thin veil of an atmosphere too fragile to sustain life as we know it. The symbolism is impossible to ignore. A lonely wanderer meets a lonely world. A story billions of years in the making collides with one written in the dust of another planet's surface. It is here, in this cosmic choreography, that anticipation builds. If Atlas continues unremarked, it may be logged, studied, and then forgotten, a scientific curiosity filed away. But if it behaves as it has already hinted, moving strangely, fragmenting in patterns, reflecting light in ways we cannot yet explain, then Mars becomes more than a bystander. It becomes the stage on which the first act of a greater mystery is played. Mars is in our sights, as it has always been. But now, for the first time, something else is in Mars' sights. A visitor whose silence carries questions we are not yet ready to answer. The first fragments of data arrived quietly, as they always do, lines of numbers, pulses of light translated into streams of code. There was no thunder, no cosmic trumpet announcing the visitor's secrets. Just photons captured by orbiters circling Mars, telescopes on Earth, and deep space instruments scattered across the solar system. To most, these numbers meant nothing. But to the few trained eyes staring into monitors, they told a story that was both precise and unsettling. 3I Atlas, the third confirmed interstellar object to pass through our system, was not behaving the way it should. At first, everything seemed familiar enough. Its path was hyperbolic, a natural trajectory for an interstellar traveler pulled momentarily into the grip of the sun. Its velocity, nearly 90,000 kilometers per hour, was astonishing, but not unprecedented. Yet as measurements accumulated, small deviations began to appear. Atlas was shifting, not dramatically, but in subtle ways that could not easily be explained. Its velocity fluctuated in patterns, inconsistent with a simple rock or icy body sailing through the void. Scientists considered the obvious explanations first. Outgassing jets of vaporized ice, like those seen in comets, can alter a body's speed and spin. But Atlas was oddly dry. No visible coma of gas, no streaming tail of dust. The instruments registered reflections that suggested a metallic sheen, not the dull gray of icebound rock. Something about its surface caught sunlight in crisp, angular flashes, as if it were more mirror than stone. Then came the second anomaly, the swarm. Telescopes noted smaller fragments trailing ATLIS, not in chaotic scatter, but in strangely coherent formation. A cloud of objects, orbiting and drifting in its wake, like fish following a leviathan. Some fragments sparkled with unusual brightness, reflecting sharply against the black. Others moved in tandem, maintaining relative positions as if tethered by invisible threads. For astrophysicists accustomed to neat equations and predictable orbits, the swarm was troubling. Natural fragmentation occurs, yes, but not with such apparent order. A comet can shed pieces, an asteroid can crumble, but the debris usually disperses into random scatter. Atlas, by contrast, seemed to hold its children close. The first whispers spread in data rooms and late-night conferences. Could it be artificial? No one wanted to say it aloud. Scientists live in fear of leaping too quickly into fantasy, of staining data with imagination. Yet the numbers persisted. The velocity shifts did not match known physics. The swarm defied easy explanation. And the reflectivity hinted at something stranger still. Surfaces too smooth, too polished, too deliberate. To grasp the full weight of this, we must remember the precedent. In 2017, the first known interstellar object, Oumuamua, had puzzled astronomers with its elongated shape, its unusual acceleration, its shimmering brightness. Some suggested cometary outgassing, others something more exotic. A few even whispered probe. But Oumuamua slipped away before the debate could be settled. Then came Borisov in 2019, a more typical comet, reassuringly familiar. Now, Atlas has arrived, and its behavior seems to lean once again toward the uncanny. This is the pattern that unsettles the scientific mind. Once could be anomaly, twice could be coincidence, but 3 times begins to feel like something else. The data pours in daily now, refined by each pass of an orbiter, each glance from Earth's largest telescopes. And the more we learn, the less it conforms. Atlas is not accelerating in random spurts, but in measured pulses. Its fragments are not drifting away, but maintaining coherence. Its surface does not scatter sunlight evenly, but returns sharp bursts, like signals. The question grows heavier. Is this an accident of physics, or a message written in motion? For centuries, humans have looked at the skies and mistaken patterns for intention. The canals of Mars, the face on the moon, the constellations etched by imagination across fields of stars. Our minds are wired to find meaning, even when none exists. Yet sometimes the meaning is real. The pulse of a pulsar, once thought to be the signal of little green men, turned out to be the heartbeat of collapsed stars. But the data was true, the mystery valid, even if the interpretation shifted. And so with Atlas, we must tread carefully. We must balance wonder with discipline, speculation with skepticism. For if the data is even half correct, we may be witnessing a phenomenon unlike anything in the record of astronomy. Imagine for a moment what that could mean. A fragment of another star system, arriving here not as a lone wanderer, but as part of a company. A swarm that clings to it, perhaps shepherded, perhaps born of it. A body that does not merely drift, but adjusts, shifts, pulses. If natural, it would rewrite our understanding of interstellar objects. If artificial, then the implications are staggering. The silence of the numbers grows loud. They press on the minds of those who study them, whispering questions they are not yet ready to voice. What is Atlas? Why does it carry companions? And why, of all paths, does it now pass near Mars? The data does not answer. It only deepens the mystery. And with every passing hour, Atlas draws closer, carrying with it a secret written in its speed, its swarm, and its impossible behavior. It is often said that the first time something happens, it is a curiosity. The second time, a coincidence. But the third time? That begins to feel like a pattern. Before Atlas, there were 2 visitors from the great silence beyond our star. And in their passing, they left us with whispers that now echo in the strange data we see today. The first arrived in 2017. Astronomers named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. It was a name chosen with care, carrying both the scientific need for designation and the poetic weight of encounter. Unlike anything ever seen before, Oumuamua was too fast to be bound by the sun. Its trajectory marked it as interstellar, the first confirmed object of its kind. But it wasn't just its speed that startled observers. Its shape, inferred from the way it reflected sunlight as it tumbled, was bizarre, possibly cigar-like, perhaps a flattened shard. Its geometry, unlike any known asteroid. Its surface shone with an odd brightness, suggesting metallic or icy composition. And most troubling of all, Oumuamua accelerated as it left the inner solar system as though nudged by invisible hands. No visible jets of gas explained the push. No coma of vapor betrayed cometary activity. It simply changed speed. For months, the scientific community wrestled with the data. Some insisted it was merely a fragment of a comet that behaved unusually. Others dared to voice what many thought, but would not say aloud. Could it have been artificial? Could Oumuamua have been a probe, a fragment of alien technology, or at least a construct shaped by processes we do not yet understand? Harvard astronomer Avi Loeb became the most outspoken proponent of this view, arguing that the simplest explanation was also the boldest, that we had just witnessed our first contact, not with the civilization itself, but with its emissary. The debate never found resolution. Oumuamua slipped beyond our reach, vanishing into the darkness, its secrets forever unmeasured. Then, in 2019, another visitor arrived, this one named 2I Borisov, after the amateur astronomer who first spotted it. Unlike Oumuamua, Borisov was comfortingly familiar. It behaved like a comet, with a gaseous tail streaming behind, releasing volatiles in ways that matched what scientists already knew. It was interstellar, yes, but not mysterious. Borisov reassured many that Oumuamua's strangeness was a one-off, an oddity not worth reshaping the foundations of astronomy. But reassurance is fragile. Now comes a TLAS, 3I at TLAS, the third visitor. And once again, the familiar balance shatters. Like Oumuamua, Atlas appears to accelerate in ways that defy simple explanations. Like Oumuamua, it gleams with unusual brightness. But unlike Oumuamua, Atlas does not travel alone. It is accompanied by a swarm, fragments moving with coherence rather than chaos. And unlike Borisov, it does not give us the comfort of behaving like an ordinary comet. What, then, are we to make of this sequence? One messenger that could have been natural, but hinted at the extraordinary. One that seemed ordinary, as if to lull us into calm. And now, a third that once again bends the rules. Is this the rhythm of chance or the cadence of intention? Some whisper of patterns. That Oumuamua was the scout, Borisov the distraction, and Atlas the approach. Others insist that human imagination is once again overreaching, turning celestial wanderers into symbols. After all, the cosmos is vast. Interstellar fragments must drift between stars in countless numbers. Surely we were bound to encounter them eventually, but still the mind lingers on the timing. 3 in just a handful of years, after human technology has finally advanced enough to notice them. 3 within the narrow window of our watchfulness, after millennia of blindness. Is this mere luck, or the awakening of a new chapter in cosmic history? Patterns, whether real or imagined, hold power. Ancient peoples saw gods in the stars, omens in the streaks of comets. Today, we see physics, probability, data. And yet, when anomalies appear, the same shiver of myth returns. The scout, the warning, the arrival. 3 voices in a silent symphony. Atlas is not just another stone from the dark. It is the third note in a melody we are only beginning to hear. And perhaps, if we listen too closely, we may wonder, is someone or something playing the tune? At first, it seemed to be a solitary traveler and object alone, crossing the great silence of interstellar space. But soon, new data revealed something stranger. 31ATLAS was not solitary at all. Trailing behind, scattered in faint lines, were smaller objects' fragmentary companions, difficult to track, yet persistent in their presence. What had seemed like a single visitor was, in truth, a procession, a swarm. Astronomers were cautious at first. Fragmentation is not unusual. Comets heat as they approach the sun, releasing volatile gases that fracture their icy cores. Pressure builds, surfaces crack, shards peel away. Some fragments drift off chaotically, some remain loosely bound, creating the appearance of an entourage. For mainstream astrophysics, this was the safe explanation. Atlas was breaking apart, just as many comets before it had done. But not everything fit neatly into the familiar. The fragments were not scattering randomly. They seemed to move with coherence, maintaining a curious formation. Some clustered in arcs, others in faint strings, as though strung along invisible threads. If this was simple debris, why did it seem ordered? The more telescopes tracked a TLAS, the more difficult it became to dismiss the anomaly. Were these just shards of ice, or was the swarm itself a structure and emergent geometry hidden in the void? History offers echoes of such wonder. Ancient sky watchers often described comets not as singular streaks, but as flocks, as fiery herds crossing the heavens. The Chinese spoke of broom stars that scattered sparks. Mesoamerican myths told of serpents whose bodies unraveled into many. Perhaps in their own way, those stories preserved the memory of swarms like this cosmic travelers, not alone, but accompanied by shadows. Mainstream science pushes us toward restraint. It is true that comets fragment often. Shoemaker-Levy 9, for instance, broke into a string of pearls before colliding with Jupiter in 1994. That event was dramatic, catastrophic even, but entirely natural. Might Atlas be enacting a similar fate, its pieces destined to disperse until only dust remains? And yet the unease lingers. Some researchers, moving beyond the bounds of conventional thinking, wonder aloud, what if the swarm is not accidental? What if the fragments are not merely breaking away, but are arranged, guided, or even designed? Could Atlas be more than a rock, and its debris could it be a convoy? One radical idea suggests the fragments could be probes, piggybacking on a larger host. A mothership, releasing scouts as it drifts through a foreign solar system. Another theory imagines von Neumann machines self-replicating devices, breaking into parts not to decay, but to multiply, to seed. In such a vision, the swarm is not collapse, but birth. Of course, extraordinary claims demand extraordinary evidence. And here, the evidence is faint, hazy, difficult to parse. Telescope data can only do so much when objects are so distant, so small. What we see could be artifacts of observation, illusions of alignment. Still, the imagery is haunting. A procession threading through space, a flock of stones or machines, an entourage to a traveler we already do not understand. Humanity has always feared swarms. Locusts, armies, storms numbers that overwhelm by sheer presence. To see that pattern in the sky awakens deep archetypes. The devouring horde, the destroyer's herald. When we project such fears onto a TLAS, perhaps we are simply echoing our own ancient instincts. But the cosmos does not need to share our fears for the danger to be real. Even a small fragment, broken loose from the swarm, could spell disaster if its path intersects Earth. A stone the size of a house could erase a city. A stone the size of a mountain could collapse civilization. A swarm magnifies the odds. The more fragments, the more chances for encounter. And so the swarm is both mystery and threat. Science demands calm. These may be mere shards, destined to harmlessly disperse. Speculation whispers something darker. They may be harbingers, scouts, or even messengers. In the quiet halls of observatories, data streams continue to arrive, lines of numbers tracing faint paths across the stars. Astronomers debate in hushed tones noise or signal, chaos or structure, natural or otherwise. But beyond the mathematics, beyond the skepticism and hope, one truth presses down like the cold of interstellar night. Atlas is not alone. It was never alone. Mars has always been more than a planet to us. It has been a mirror for our fears, our ambitions, our stories. A world painted red by iron dust, circling like a restless ember in the night sky. To ancient cultures, it was a god of war, a herald of omen. To modern science, it is a destination one step closer to becoming interplanetary. Yet in the long history of watching Mars, shadows have always lingered, strange shadows. In 1877, Italian astronomer Giovanni Schiaparelli reported seeing canali lines etched across the Martian surface. His word was mistranslated into canals, and suddenly the world was seized by the idea that Mars was a world of engineers, a civilization carving waterways into a dying planet. Telescopes trembled with hope and fear. Could we be staring at neighbors, etched in stone? Later, photographs from orbit revealed no canals, only the tricks of optics, the human brain forcing order on chaos. But the dream of a Martian presence had already been planted. Then came the lights. For more than a century, scattered reports told of flashes on the Martian surface, bright glimmers that flared, then vanished. Were they storms reflecting sunlight? Dust devils catching the angle just right? Or were they something stranger, signals from a place we could only watch from afar? Even into the 20th century, observatories recorded transient events on Mars' short-lived luminous spots, unexplainable but undeniable. Dust itself became part of the enigma. Mars is a planet alive with storms, its thin atmosphere whipping fine grains into global veils. In 1971, Mariner 9 arrived at Mars only to find the entire planet smothered beneath a single storm, a shroud of ochre hiding every feature. The red planet had vanished behind its own breath. When the storm cleared, new dark markings appeared on the surface, shadows born of dust or something more. Even Mars' orbit has not escaped curiosity. In the 19th century, small deviations in its motion were noted, leading some to speculate about undiscovered bodies tugging invisibly at it. Phantom planets, hidden moons, unseen hands, bending the trajectory of a world. While modern measurements corrected most of these anomalies, the whispers remain, a planet whose dance is never entirely its own. Why do these shadows matter now? Because 3I Atlas is approaching Mars. And if Mars has always been a stage for mysteries, the arrival of something alien, something interstellar, adds a new layer to the story. Imagine the view: a faint interstellar object slipping past the orbit of Mars, accompanied by its swarm of fragments. Imagine those fragments crossing the thin Martian atmosphere, igniting as brief fireballs above the rusted deserts. Imagine how easily, from a distance, such events could become more of the odd lights recorded in centuries past. Were those flashes only dust storms or echoes of earlier visitors like Atlas, passing quietly, leaving shadows behind? It is tempting to dismiss such speculation. Science is built on caution, on not leaping too quickly into wonder. But history shows how often Mars has deceived us, how often we've seen too much or perhaps too little. Perhaps the red planet has been a mirror, not just for our imagination, but for real cosmic encounters. And so, when we say that Atlas is closing in on Mars, there is a chill that runs deeper than astronomy. Mars has always been the planet of shadows. Shadows of myth, shadows of war, shadows of mystery. If Atlas carries companions, if its swarm stirs as it passes, then the next chapter in the Martian record may be written not in canals or lights, but in something more unsettling, a reminder that Mars has always been a stage, and perhaps we have always been the audience of a play we barely understand. Space is not empty. It is a vast ocean of subtle forces, invisible hands tugging and pushing, guiding every object that drifts across its dark expanse. To understand why Three-Eye Atlas unsettles astronomers, we must first understand the rules of this ocean, the mechanics of the interstellar. At its simplest, motion through the cosmos is governed by gravity. A planet curves the path of a comet. A star's pull bends light itself. A galaxy holds its spiral arms with a silent grip, invisible but absolute. For centuries, Newton and later Einstein gave us the tools to predict these motions with extraordinary precision. Every rock, every icy fragment, every visitor from the deep between the stars should follow these rules without exception. For small, low-mass bodies, cometary dust, fragments of ice, this pressure can accumulate into a noticeable effect, bending their paths ever so slightly. Over millions of kilometers, such nudges can shift trajectories in ways that mathematics must strain to capture. Then there is outgassing, the release of volatile material. A comet approaching a star vents its frozen heart, jetting streams of gas and dust like miniature thrusters. This, too, can alter an orbit, making it deviate from the clean line of gravity. But such activity leaves signs, tails, plumes, a signature of sublimating ice. With Three-Eye Atlas, those signs are conspicuously absent. This is where unease begins. The motion of Atlas suggests forces at play beyond simple gravitation, but the usual suspects, radiation pressure, cometary outgassing, do not fit. Its trajectory bends more than it should. Its velocity shifts subtly against expectation, as if something unseen were propelling it. The first interstellar object ever discovered, 1I Oumuamua, raised the same question. Its sudden acceleration could not be fully explained by cometary venting, and its shape, possibly a thin, elongated shard, made it unusually susceptible to radiation pressure. Some argued it might be no natural rock at all, but a fragment of something engineered, a wafer-thin sail drifting between stars. Now, with Atlas, we see echoes of this puzzle, magnified. Its fragments trail it like a school of fish, navigating currents we cannot see. Are they obeying ordinary celestial mechanics, or is there an additional hand guiding them? The mathematics grows uneasy here. If Atlas were large, dense, and inert, its course should be predictable within fractions of a kilometer. Instead, astronomers report deviations small, but persistent. Models strain. Equations wobble. The interstellar ocean behaves strangely. It forces us to consider not only the obvious forces, but the forgotten ones. Galactic tides, the gravitational tug of the Milky Way itself, acting like slow waves across billions of years. Interstellar drag, the friction of rarefied hydrogen atoms against a speeding body. Magnetic interactions, subtle and faint. Each could, in theory, alter an object's course. But none explain why Atlas behaves so distinctly different from the norm. There is also the possibility that our instruments deceive us, that what we interpret as anomalies are simply errors of measurement dust in the lens of cosmic observation. Yet, as data accumulates, the pattern sharpens instead of blurring. The anomaly persists. And so, Atlas sits at the crossroads of science and speculation. It is not yet evidence of anything extraordinary, but it is evidence of something unexplained. The kind of evidence that demands we widen our frame of reference and remember that physics is not a finished book, but a manuscript still being written in the margins of the universe. Interstellar mechanics reminds us of humility. Every law we trust is provisional, every prediction a model of reality, not reality itself. Atlas is not breaking the rules, it is showing us where the rules are incomplete. For centuries, we have learned from anomalies. The orbit of Uranus once betrayed the presence of Neptune. The trembling of Mercury revealed Einstein's relativity. Each shadow in the data has been a lantern pointing us deeper into the structure of the cosmos. Perhaps Atlas, too, is such a lantern guiding us toward a physics not yet named. The interstellar ocean is vast. We are new sailors, our maps half drawn. And into that ocean drifts a TLAS, not a rogue wave, but something subtler, a current we do not yet understand. A reminder that in the great mechanics of the cosmos, even silence can leave ripples. Mars has never been just another planet in the night sky. It is a wandering flame, a red ember drifting among the constellations, its rusty hue unmistakable. To the ancients, this glow was not the reflection of sunlight off iron-rich dust, but the beating heart of war, blood, and omen. When Mars rose, entire civilizations trembled. In Greece, the red planet bore the name Ares, the god of war. To see it bright and near was to see the looming shadow of conflict, as if the heavens themselves signaled that armies would soon march and nations would bleed. The Romans inherited this vision, renaming the god Mars, and entwining his planetary namesake into their very identity. To invoke Mars was to summon not only war, but the strength and fury to endure it. Far older myths echo the same association. In Mesopotamia, Mars was Nergal, a god of plague and the underworld. His arrival in the skies was taken as an omen of pestilence, famine, or the fall of kings. The Babylonians tracked its motions carefully, weaving celestial mathematics with divine warning. To them, the Red Wanderer was less a planet and more a celestial decree. Even in the ancient Americas, Mars held a place of dread and awe. The Maya recorded its cycles, binding its oppositions and conjunctions to prophecies of strife. The Incas, too, looked to the red planet as a fiery spirit, sometimes a harbinger, sometimes a guardian, always a force to be reckoned with. Why Mars? Why did humanity across continents, separated by oceans and epochs, give the same symbolic weight to a single point of light? Perhaps the answer lies in its color. Red is the color of blood, of fire, of the setting sun. In the darkness of the ancient night, Mars was the one planet that burned with that unmistakable hue, a cosmic ember in a sea of white stars. To human eyes attuned to survival, that red glow could not be ignored. But color alone does not explain the weight of myth. The movements of Mars reinforced its ominous reputation. Unlike the steady stars, planets wander. They slow, they loop backward in retrograde. They defy the normal rhythms of the heavens. To early astronomers, this was a kind of celestial rebellion, a god who refused order, whose path was as unpredictable as war itself. Thus Mars became a canvas for memory, a mirror onto which humanity projected its greatest fears and its most violent cycles. Each war, each plague, each upheaval could be tied to its rising, reinforcing the myth with every turn of history's wheel. It was not only the planet that moved, it was the human imagination, tethered to it, weaving story into orbit. Now in the age of telescopes and spacecraft, we know Mars as a world of dust storms and canyons, a planet once wet, now dry. And yet the old memory lingers. Every close approach rekindles fascination. Each mission we send carries whispers of the same myth, that to reach Mars is to confront something deep within ourselves. We cloak the planet in science, but beneath the equations, the archetype remains Mars as omen, Mars as mirror. And so, as 3IATLA drifts toward the orbit of Mars, the resonance is unmistakable. It is not only an interstellar visitor we watch, but the old god's domain. A red world that has always been bound to human fear now becomes the stage for a cosmic encounter. For scientists, it is data. For dreamers, it is prophecy. For history, it is continuity. Perhaps this is why Atlas unsettles us more near Mars than anywhere else. Deep down, we are not just observing mechanics and rock. We are remembering. We are echoing the voices of our ancestors who looked up at that same red glow and saw war, pestilence, and upheaval on the horizon. The myths may have faded, but the memory remains. Mars has always been a harbinger, and when something alien drifts close to it, we cannot help but feel that omen stir again. At first, it was only a whisper in the numbers. The data seemed ordinary, another line in the endless stream of measurements pouring from telescopes and tracking arrays. But then, as astronomers compared the latest readings, something subtle emerged. 31ATLAS was not simply coasting through space. It was accelerating. In the vacuum between planets, objects behave predictably. They follow Newton's laws like dancers, moving to an ancient rhythm. Every orbit, every trajectory, every gentle tug of gravity can be calculated with exquisite precision. When an interstellar visitor enters our system, it should obey those same rules. Gravity from the sun should pull it inward. Radiation pressure from sunlight may nudge it slightly. Outgassing, if it were a comet, could provide small, erratic boosts. But Atlas was different. The numbers showed a deviation tiny at first, but undeniable. Its velocity near Mars did not match what gravity alone could account for. It was as though some invisible hand had brushed against it, accelerating it by a margin that should not exist. Scientists began their litany of explanations. Perhaps it was outgassing, jets of vaporized ice hidden in the glare. Yet telescopes detected no telltale coma, no shimmering tail of dust. Perhaps it was radiation pressure, the gentle push of photons. Yet for that to explain the motion, Atlas would need to be impossibly thin, more like a reflective sail than a natural fragment. These arguments echoed a story we thought we had left behind. In 2017, another object, Oumuamua, displayed the same inexplicable acceleration, sparking fierce debate. Some argued it was a shard of frozen hydrogen, venting invisibly. Others suggested exotic explanations, even the possibility of an artificial probe. With Atlas, the echoes were too strong to ignore. But here, near Mars, the stakes felt different. Oumuamua had already slipped past us, vanishing into the dark. Atlas was still within reach, still moving through a realm we could observe. Each anomaly added weight to the question. What kind of travel accelerates without thrust, without fuel, without reason? Some whispered about tidal effects, faint interactions with the planet's gravity well. Others proposed unmeasured forces. Plasma streams, interplanetary magnetic fields, hidden swarms of debris exchanging momentum. Yet the models strained under the burden. Each new explanation bent physics further without quite fitting. And so, the thought lingered. What if Atlas was not obeying physics as we know it? In the silence of deep space, acceleration is more than a number, it is intent. A rock drifts, a ship moves. The difference is measured not in material but in purpose. When something changes its path without cause, the human mind cannot help but ask, who or what is doing the steering? The idea is unsettling because acceleration implies control. If Atlas is natural, then it should be passive, tossed like driftwood on a cosmic tide. But if its acceleration defies explanation, it suggests agency or a law of nature we have yet to discover. Either answer is profound. The closer we look, the more the mystery deepens. Instruments detect a subtle consistency in the anomaly, not the random flicker of cometary jets, but a steady, smooth adjustment. As though Atlas is correcting itself, maintaining a course invisible to our charts. Not wild, not chaotic deliberate. Skeptics remind us that science thrives on caution. Nature has ways of surprising us, and every anomaly is a lesson waiting to be solved. But still, the imagination resists dismissal. Could Atlas be more than a fragment? Could it be a vessel, a probe, or even a shard of something larger, obeying principles beyond our reach? We stand once again at the edge of knowledge. The impossible acceleration is not proof of anything, but it is a signal and invitation to wonder. The cosmos does not give up its secrets easily, and sometimes the only way forward is to admit that the map we hold may be incomplete. For now, Atlas continues its journey, slipping past Mars with a motion that defies prediction. We track it, we measure it, We argue over it. But deep down, a truth hums beneath the equations. We are watching something that does not quite belong. And so the question lingers, as it did with Oumuamua. Is this the signature of new physics, or the faint whisper of something far stranger? There are nights in history when the heavens seem to lean closer, when the red eye of Mars and the luminous tail of a comet shared the same patch of sky. To the people who lived beneath those skies, it was not a coincidence. It was a sign. One such story comes to us from the late 1st century BCE, during the reign of Julius Caesar. Roman chroniclers tell of a blazing comet that appeared near the planet Mars, its tail streaking across the sky like a fiery sword. To the legionnaires and citizens alike, Mars was already the god of war, the harbinger of conflict. A comet passing close to that crimson light was read as confirmation that battle was not only near, it was inevitable. And indeed, in those same years, Rome was racked by civil war. Alliances crumbled, republics burned, and new orders rose from the ashes. To the Roman mind, the comet had not merely foreshadowed these events, it had called them into being. Across the centuries, similar patterns echo. Babylonian sky watchers kept meticulous records on clay tablets, marking every unusual conjunction of Mars with wandering stars or comets. They feared such unions as omens of kings' deaths and empires' collapse. The priests of Nergal, their war god associated with Mars, would sound warnings of pestilence and invasion whenever the red planet danced too close to a comet's path. Even in more recent times, the link between Mars, comets, and catastrophe has resurfaced. In 1881, astronomers observed a comet appearing in Mars' vicinity. Though modern science dismissed the event as ordinary celestial mechanics, newspapers of the day buzzed with speculation. Some writers warned of disaster for Europe, while others spun tales of Martian civilizations, sending fiery messengers across the void. Fiction and fear intertwined, as they so often do when Mars is involved. There is something uniquely unsettling about the red planet and the wandering flame of a comet sharing the same sky. Perhaps it is the color, the blood-like glow of Mars, paired with the ghostly silver of the comet. Perhaps it is the timing comets often appear suddenly, without warning, their arrival seeming almost theatrical. Or perhaps it is something deeper, an intuition, ancient and half-buried, that when Mars and comets meet, history itself is about to shift. In art and myth, this imagery repeats like a drumbeat. Medieval manuscripts depict Mars alongside flaming stars, etched with captions of plague and conquest. In Hindu cosmology, celestial wanderers appear during cosmic ages of strife, often in proximity to red or fiery omens. The Hopi people of North America speak of a red star that will herald great purification, a prophecy that resonates eerily with the image of Mars joined by a comet's fire. And so we return to the present. As 3IAT-LAS drifts nearer to Mars, scientists reassure us with models, equations, and probabilities. They speak of ice and dust, of orbital paths and gravitational tides. But outside the language of science, a whisper runs deeper. We have seen this before. We have written it in stone, sung it in hymns, carved it into myths. When Mars burns bright and a comet lingers near, the world listens. Whether coincidence or pattern, the effect on the human imagination is undeniable. Mars is never just another planet. It is the battlefield, the omen bearer, the restless god cloaked in iron dust, and a comet is never just another rock. It is a messenger, a wanderer, a herald of change. Together, they form an image so charged with meaning that across centuries, across cultures, we have responded with awe, fear, and trembling anticipation. Now, with a TLAS, that image comes alive once more. A red planet, a silent intruder, a path that defies certainty. History's stories rise like echoes, reminding us that even if the universe is indifferent, humanity has always read the sky as if it were a mirror. The comet near Mars is no longer just a point of light in the telescope. It is a question stretching back thousands of years. Are we watching the heavens, or are the heavens, in some way, watching us? In the cold arithmetic of astrophysics, fragments are inevitable. A comet approaches a star. Heat fractures its icy shell. Gravity tugs unevenly at its body. And what was once whole splinters into a cloud of companions. Most astronomers believe this is all we are seeing with 3I Atlas, a natural comet shedding its skin as it drifts past our sun. And yet, the data tells a more complicated story. Some of the objects trailing a TLAS do not behave like simple debris. Their spacing appears oddly consistent, as if locked into invisible lanes. Their brightness flickers, not with a random tumbling of shattered rock, but in rhythms that suggest synchronization. To the cautious mind, these patterns could be coincidence. To the curious mind, they are an invitation to wonder. What if these are not fragments at all? What if they are sentinels? The idea is not new. In the 1940s, the mathematician John von Neumann speculated on self-replicating machines that could cross the galaxy. Such probes, designed to multiply using raw material from asteroids and comets, could spread like seeds on the solar wind. If they existed, we might never see the machine itself, but we might glimpse the trail of fragments, each one more than what it appears. Some suggest the Atlas swarm could be precisely this, a disguised convoy of probes hiding in the camouflage of cometary debris. To our telescopes, they look like ice and dust, but hidden within could be patterns of control, propulsion, or transmission. Others imagine something subtler, cosmic shepherding. In Saturn's rings, small moons guide swarms of ice into stable paths, creating lanes and gaps. Could Atlas itself be a shepherd? A larger body guiding smaller ones, not for aesthetics, but for purpose? Perhaps mapping gravitational fields, perhaps scanning planets as they pass, perhaps waiting for something or someone to answer back. Skeptics dismiss these notions as pareidolia, the human tendency to see order where there is none. After all, space is vast, and chaos can mimic structure. But still, the question lingers. If even a single anomaly in the swarm's motion cannot be explained by ice, rock, or dust, what does that imply? The philosophical weight of such a possibility is staggering. If these fragments are sentinels, then Atlas is not just a visitor, it is a messenger. And what message does it carry? Observation? Warning? Invitation? Or something we cannot yet imagine? Human history offers strange parallels. Ancient travelers lit beacon fires on hilltops, guiding companions through the dark. Mariners released flares across the ocean to signal their fleets. Could the cosmos itself carry out the same ritual, sending swarms of glowing bodies to mark a path, to declare presence, to announce intent? And if so, why now? Why near Mars? For every scientific model that frames Atlas as ordinary, there exists a whisper of unease, that the universe is not merely a field of dust and gravity, but a stage where intelligence ours or another's plays out across distances so vast we can barely comprehend. If Atlas is fragment, then the story is simple, a rock breaking apart as it always would. But if Atlas is sentinel, then the story is very different. It is no longer about what we see, it is about who is watching. Perhaps we are not just tracking an object through space. Perhaps we are being observed in return, measured by our responses, judged by our readiness. The swarm drifts on, silent, unblinking. Whether debris or design, it forces us to confront the deeper question. How much of the cosmos do we truly understand, and how much of it is a language we have not yet learned to read? But whether fragments or sentinels, their presence reminds us of something more immediate, the vulnerability of the world beneath our feet. For if the heavens are sending messages, they may not always arrive gently. From the first flicker of fire to the distant hum of radio waves, humanity has always reached outward, sending signals into the darkness. Long before telescopes and satellites, our ancestors lit bonfires on hilltops, sent smoke across valleys, or etched patterns into stone. These acts, simple and human, were attempts to be seen, to be heard, to leave a trace in a world that felt immense and indifferent. Today, those acts have multiplied beyond imagination. Pulses of data stream from Earth in every direction: radio, television, radar, and now, precise probes scanning the heavens. Every ping, every broadcast, reaches far beyond our planetary neighborhood, slipping past Mars, Jupiter, and the asteroid belt into a void that has remained mostly silent for billions of years. We have become unintentional heralds. Our technology, a beacon that might draw attention in ways we cannot predict. And then comes 3IATLAs, cutting through the void with its mysterious companions, its trajectory puzzling, its behavior defying expectation. Is it coincidence that this interstellar wanderer approaches while we radiate signals into the cosmos with ever-increasing intensity? Or, in some deeper sense, are we callers, unwittingly drawing the attention of a universe that has remained unseen? Science offers explanations grounded in physics. Stars eject matter, comets drift through the galaxy, gravity shapes trajectories. ATLAS could simply be another fragment of a long-lost system, tumbling toward us by random chance. Yet, the patterns we observe, the swarm, the velocity, the timing hint at a curious alignment, one that resonates with an almost mythic notion that by reaching outward, we might also attract. Throughout history, cultures have imagined this dynamic in metaphor and ritual. The Hopi sent prayers to the sky, hoping to influence storms and harvests. Vedic priests intoned hymns intended to call divine forces to the earth. In medieval Europe, astronomers and astrologers alike believed that human intention could bend the heavens, that our thoughts, actions, and ceremonies were linked to the movement of stars and comets. Science may have replaced ritual with telescope and algorithm, but the human instinct to project influence outward remains. Modern technology may simply be a sophisticated extension of that instinct. Deep space observatories, high-frequency radio transmissions, and laser communication systems act as massive signals, pulsing into the darkness. And even as we observe, we participate in a feedback loop. We watch the sky reacts, and we interpret that reaction, sometimes as mere data, sometimes as a story. Consider the implications. If 3I Atlas and its swarm were influenced even subtly by these signals, by our radio chatter, by our energy outputs, by our planetary activity, then the act of observation itself becomes a kind of call. Every telescope sweep, every radar ping, every probe sent toward the stars is not neutral. It is a gesture, intentional or not, into the cosmic void. Yet, this is not to suggest that the universe is sentient in a human sense. It may not listen in the way we understand listening, but the idea remains compelling that human presence, human curiosity, human reach, our very act of probing the cosmos creates ripples that might intersect with objects like a TLAS. In this view, we are not passive observers. We are participants, coaxing, beckoning, perhaps even challenging the vast expanse of space. And so, the reflection deepens. Are the strange arrivals, the swarms, the anomalies, simply part of a galaxy indifferent to us? Or are they, in some sense, echoes of our own curiosity, reverberations of our reach? We have always looked outward in search of answers, but perhaps the universe looks back with consequences we cannot yet measure. As Atlas continues its journey toward Mars, we confront a quiet paradox. By trying to understand the cosmos, we may have become part of the story we are trying to read. Our instruments, our broadcasts, our relentless gaze, these are not just tools of knowledge. They are the calls of a species aware of its smallness, but daring to reach across the void. And sometimes, the cosmos answers. But as we send our calls into the heavens, Another question arises. What does it mean when the universe seems to respond? For Atlas may be more than a wanderer. It may be a reflection of the intentions we did not know we had. Mars, with its rust-colored plains and whisper-thin atmosphere, is a world on the edge. Its air is but a trace of what Earth's breath offers, barely enough to carry heat, barely enough to shield the surface from the relentless bombardment of space. Here, a fragment that might seem inconsequential to our planet can become catastrophic. A small comet or asteroid passing through the Martian system could ignite dust storms that blanket continents, trigger temperature swings, or release unseen chemical reactions in the atmosphere. And yet, it is precisely these vulnerabilities that make Mars a mirror for our own world. Earth may be more forgiving, with oceans and winds to absorb shocks, but the principle remains. Even minor cosmic events have cascading consequences. A fragment too small to leave a crater on Mars could, through the subtle dynamics of orbital mechanics, strike at the perfect angle to disturb atmospheric balance, or nudge other debris into new, unexpected trajectories. Observations of 3I Atlas reveal hints of this delicate dance. Its swarm, whether fragments, companions, or sentinels, approaches Mars with velocities that defy simple explanation. Each piece carries potential energy, not merely in kinetic terms, but as a catalyst for environmental disturbance. On Mars, where seasons are fragile and weather patterns sensitive, a single near miss could stir winds that persist for weeks, even months, altering surface conditions in ways that ripple across the entire planet. In this, scientists see a lesson for Earth. Our atmosphere is thicker, our magnetic field protective, yet history reminds us of vulnerability. Tunguska in 1908, Chelyabinsk in 2013, and the mass extinctions recorded in the fossil archive all testify. Cosmic fragments, large or small, matter. The chaotic ballet of objects in space does not discriminate, and the boundary between minor disruption and global crisis is thinner than we often admit. Mars provides a living laboratory for understanding these thresholds. Dust storms that engulf entire hemispheres, sudden temperature fluctuations, the shifting polar ice caps all are examples of an environment poised to respond dramatically to small perturbations. Scientists model these events not merely to predict Martian weather, but to refine our understanding of fragility in planetary systems. Every calculation of Atlas trajectory, every simulation of its swarm's passage, is a meditation on cause and effect at cosmic scales. Yet beyond the numbers lies something more philosophical. Watching Mars struggle to maintain balance in a harsh and indifferent cosmos, we are reminded of the tenuous grip of life on any planet. Our own biosphere, offered by oceans, forests, and the complex web of life, is a system of improbable equilibrium. It may feel permanent, yet it rests on a knife's edge. Atlas' journey past Mars is a quiet celestial reminder. Stability is temporary, and vulnerability is universal. Cultural reflections echo this lesson. In mythology, red planets often signify blood, war, and upheaval. Mars, Ares, Nergal symbols of instability and sudden change. The ancients intuited that distant objects could carry influence, not unlike our modern awareness that a fragment from interstellar space could tilt climates, redirect dust, or catalyze chain reactions. The cosmic and the human imagination converge in this understanding. Fragility is not merely a scientific observation. It is a narrative we have carried for millennia. The swarm around Atlas magnifies this reflection. Each fragment, moving with precision that seems almost deliberate, becomes a test of resilience. Mars' thin veil of air cannot absorb mistakes, cannot buffer surprises. And as we extrapolate to Earth, the implications are sobering. Our own dense atmosphere, our magnetic field, our oceans, these shields are remarkable, but not infinite. Cosmic events, however improbable, have the power to bypass our protections, triggering effects we may not anticipate until it is too late. Ultimately, observing Atlas near Mars is more than a scientific exercise. It is a meditation on thresholds, on the delicate interplay of mass, energy, and time. It reminds us that every celestial object carries with it the possibility of transformation, that even the smallest participant in the cosmic ballet can have outsized effects. And perhaps, in watching Mars endure, we glimpse the fragility and resilience of our own world, poised in the vast, indifferent expanse of space. And as Mars responds to distant nudges, Earth remains the stage where cosmic whispers become tangible reality. We are observers, but also participants, and every trajectory traced in the heavens challenges our assumptions about safety, stability, and survival. In the early years of the 21st century, a peculiar observation caught the attention of planetary scientists. A vast dust storm had erupted across the northern hemisphere of Mars, spreading with unusual speed and intensity, far beyond what seasonal models predicted. The storm was not catastrophic by earthly standards. Mars' atmosphere is thin, but its sudden appearance and scale were enough to pique curiosity, even concern. What made the event more intriguing was its timing. Orbital data showed that just days before the storm's onset, a small, unidentified object had swept past Mars. It was neither a known asteroid nor a fragment from the asteroid belt. Telescopes had caught only a fleeting glimpse, a faint trace against the blackness. Yet the storm followed almost immediately, as if the planet itself had responded to the passing visitor. Scientists analyzed every variable: atmospheric pressure, temperature gradients, solar radiation, all were accounted for. Nothing in Mars' predictable climate could explain the storm's rapid initiation and its erratic behavior. Some speculated that electrostatic interactions, perhaps triggered by the object's passage, had stirred dust from the surface. Others suggested gravitational perturbations, subtle nudges that, amplified across the thin atmosphere, set vast clouds into motion. Even the most conservative explanations carried an element of mystery. How could a passing object, so small and fleeting, unleash a chain reaction capable of producing continent-spanning dust storms? Models were updated, simulations rerun, but the storm retained its unpredictability, leaving scientists with more questions than answers. And yet, in the shadow of this anomaly, human imagination could not resist speculation. Was the object merely a fragment of an interstellar wanderer, like a TLAS, passing silently through our solar system? Could it have carried remnants of gas or dust that interacted with Mars' atmosphere? Or, in a more cinematic interpretation, was the planet reacting to something else entirely, an unseen influence brushing past the red world, invisible to our instruments but palpable in its effects? Observers recalled similar patterns from history, subtle reminders that celestial events can ripple in unforeseen ways. On Earth, meteor showers sometimes precede electrical storms. Comets occasionally coincide with climatic anomalies or human-recorded omens. While correlation does not imply causation, Mars dust mystery served as a vivid illustration of the complexity and sensitivity of planetary systems, and the invisible threads that connect them to the objects that traverse space. The storm itself lasted for weeks, painting the landscape in shifting ochres and deep rusts, a visual spectacle caught by orbiting cameras. Dust swirled into towering plumes, creating shadows and contrasts that seemed almost alive. Scientists monitored the event carefully, knowing that any misinterpretation could lead to erroneous conclusions about planetary behavior or worse, about the nature of the passing object. In the end, the Martian dust storm remained partially unexplained, a microcosm of the larger mysteries presented by 3I Atlas and its companions. It was a subtle reminder that even seemingly minor celestial bodies can provoke dramatic responses from worlds they pass near. The storm was both natural and enigmatic, governed by physics yet defiant of expectation, a delicate dance between chance and pattern. As Atlas edges closer to Mars, this microstory serves as a cautionary illustration. The cosmos is not merely a backdrop for human observation. It is interactive, dynamic, and occasionally startling. Dust storms, velocity anomalies, fragment swarms, each is a signal, a whisper, a subtle manifestation of forces at play far beyond our control. And like the Martian storm, their consequences can be immediate, unanticipated, and profound. But Mars is only a prelude. As Atlas continues its approach, we must consider not only the planet's reaction, but the broader cosmic consequences, how even small interstellar visitors can challenge our assumptions about order, chance, and the fragile balance of worlds. Long before telescopes scanned the skies and spacecraft orbited Mars, humanity watched the heavens with a mix of wonder and trepidation. The red planet itself burning bright against the night has inspired myths across continents and epochs. In Mesopotamia, Nergal, the god of war and plague, carried the color of Mars as a harbinger of death and chaos. In Greece, Ares rode the crimson sphere as a symbol of conflict, blood, and cosmic unrest. And among the Hopi and other Native American cultures, red stars in the sky were often interpreted as warnings, omens that required ritual attention or spiritual readiness. These ancient observers lacked our modern instruments, yet they recorded patterns, anomalies, and extraordinary events with remarkable fidelity. Chronicles speak of fiery streaks, sudden flares, and unusual lights that darted across the heavens. Could these have been comets, meteors, or fragments of interstellar wanderers, similar to 3IATLAS? Or were they phenomena now lost to history, subtle whispers of cosmic visitors that our ancestors interpreted as messages from the divine? Across cultures, recurring themes emerge. Many myths described red stars appearing before catastrophic events, wars, famine, or societal collapse. In Hindu texts, the Kali Yuga is heralded by celestial disruptions. Texts speak of flaming objects crossing the sky, leaving fear and transformation in their wake. Could these stories, passed down through generations, represent encoded memories of actual cosmic phenomena? The possibility is tantalizing. The past may have been subtly attentive to the same interstellar patterns we now detect through sophisticated instruments. Modern science rarely entertains these analogies openly, but the parallels are striking. 3.1 Atlas, with its anomalous trajectory and fragmenting swarm, recalls those descriptions. A visitor from the void, luminous or reflected, unpredictable, and potentially transformative. Just as ancient observers looked at Mars and other celestial lights with awe and caution, so too do contemporary astronomers follow Atlas' path with precision and concern. Consider the Egyptians, whose priests meticulously recorded the motions of the planets and stars. Red skies or unusual celestial appearances were often seen as messages from the gods, sometimes interpreted as warnings of upheaval. Could Atlas, approaching Mars and trailing its own entourage of fragments, evoke the same psychological resonance as those red omens of millennia past? Are our telescopes and spectrographs simply modern extensions of those ancient eyes, decoding a message our ancestors received in narrative, ritual, and myth? The consistency of these motifs is compelling. Ancient China recorded guest stars, sudden appearances in the night sky that vanished without trace. In some cases, these were supernova, but in others, the reports described rapid, comet-like trajectories. In each culture, the appearance of unusual cosmic visitors is linked to change, often abrupt, frequently unsettling. When Atlas streaks past Mars, bringing new data that challenges our understanding, it mirrors the ancient experience, a celestial presence that provokes both curiosity and apprehension. Yet, the lessons are not solely ominous. Myths serve as memory, teaching caution, observation, and respect for forces beyond human control. The ancients encoded a wisdom born of attention to the cosmos. Today, as we analyze Atlas' trajectory, velocity, and anomalous swarm, we continue the same endeavor, observing, recording, and interpreting the signals that arrive from the void. In this light, the past and present converge, revealing a continuity of human fascination with visitors from the stars. We may never know whether ancient accounts were literal observations or allegorical stories, but the resonance with modern phenomena is uncanny. The red glow of Mars, the flash of an unexpected comet, the sudden sweep of a meteor shower, all are reminders that humanity has long been attuned to the interplay of celestial mechanics and human perception. Atlas passage evokes that ancient attentiveness, prompting reflection on what we notice, what we fear, and what we remember about the sky. In the end, the ancient echoes are more than stories. They are a bridge between myth and science. They remind us that the cosmos has always been an active participant in human consciousness. Just as our ancestors interpreted red omens and strange lights as messages or warnings, so too must we consider the implications of 3 IATLAS. It is a visitor from the void, yes, but it is also a mirror, reflecting our fascination, our fear, and our ceaseless desire to understand the universe that surrounds us. And as we look back through the lens of history, the echoes of ancient observers merge with the whispers of modern data. The question emerges, are these cosmic arrivals random, or do they follow a pattern that humanity has long sensed, but only now begins to quantify? As 3 IATLAS closes in on Mars, conventional astrophysics struggles to fully explain its peculiar behavior. Observations reveal subtle accelerations, minute shifts in trajectory, and the presence of trailing fragments that defy simple gravitational models. While mainstream science leans toward cometary activity or solar radiation pressure, a growing number of theorists propose that forces we do not yet fully understand may be at play, a subtle hint that our knowledge of the cosmos remains incomplete. One possibility lies in magnetic interactions. Mars possesses only a patchwork of magnetic fields, relics of its ancient global magnetosphere. Could a highly magnetized interstellar body like a TLAS interact with these remnants in ways that influence its path or disturb its trailing swarm? On Earth, we observe charged particles in the solar wind affecting satellites and spacecraft. Could similar amplified effects be occurring on Mars, but on a scale and in a pattern unfamiliar to our models? The notion is not purely speculative. Laboratory experiments have shown that charged bodies moving through magnetic anomalies can produce unpredictable accelerations. Beyond magnetism, some scientists consider the role of unknown radiation. Cosmic rays, gamma bursts, or exotic particles may interact with interstellar objects in subtle ways. Atlas, reflective surface, hints at unusual composition, perhaps rich in metals or compounds sensitive to high-energy fields. Could exposure to these invisible forces alter the trajectory of its fragments, creating the appearance of a structured swarm? The idea is tantalizing. A natural object behaving almost as if it were guided, but without any conscious intent. Quantum effects, though more speculative, also enter the discussion. Quantum entanglement and vacuum fluctuations are phenomena typically confined to the microscopic scale. Yet some theorists propose that under extreme conditions, high velocities, low mass, or exposure to intense cosmic radiation, quantum behaviors might scale up in unexpected ways. Could entanglement between particles within Atlas and the solar system create forces that manifest as minute shifts in motion? While this borders on conjecture, the anomalies observed demand that unconventional possibilities be considered. Then there are theories about the very structure of space itself. Modified gravity models, extra dimensions, or subtle curvature in spacetime could influence objects passing through planetary neighborhoods. Atlas' approach to Mars might intersect regions where classical physics slightly diverges from predictions, causing deviations in motion that appear impossible to our instruments. The concept stretches our imagination, but it also reinforces a humbling truth. Even in the age of advanced telescopes and sophisticated simulations, the universe retains layers of mystery. Critics caution against overinterpretation. Most deviations can eventually be accounted for by mundane physics. Outgassing, minor mass loss, or solar radiation pressure variations. Yet the persistence of anomalies, particularly the apparent alignment and coherence of Atlas, trailing fragments, invites deeper inquiry. Are these small perturbations purely random, or do they hint at hidden rules, subtle forces that we have yet to codify? The distinction is not merely academic. It affects how we predict trajectories, assess potential hazards, and understand the nature of interstellar wanderers. Historical perspective adds nuance. Almua and Borisov both exhibited behaviors initially deemed inexplicable, prompting similar debates. In each case, the anomalies sparked creative scientific inquiry, leading to refined models of cometary physics, interstellar travel, and solar interactions. Atlas continues this lineage, but with an added twist. It approaches Mars, a planet with a history of human observation, mythic significance, and scientific scrutiny. The stakes are both empirical and psychological, bridging the gap between hard data and human wonder. Ultimately, the exploration of alternative physics is a meditation on humility. The universe is vast, its rules subtle and layered, and our instruments, no matter how sophisticated, are limited. By considering magnetic anomalies, unknown radiation, quantum effects, and modifications to classical gravity, we remind ourselves that the cosmos may operate under principles still beyond our grasp. Atlas' journey past Mars is not just an observational event. It is an invitation to expand our thinking, to balance skepticism with openness, and to embrace the possibility that the universe holds surprises far stranger than our imagination can yet encompass. Each theory, whether grounded in rigorous mathematics or inspired by speculation, serves a purpose. They challenge assumptions, provoke experiments, and refine models. They also illuminate a profound truth. Anomalies are not failures of science. They are guides, pointing toward phenomena that have yet to be fully understood. Atlas is a teacher as much as it is an interstellar visitor, reminding humanity that curiosity and caution must travel hand in hand. But as we contemplate forces unseen and principles untested, another question emerges. Could these anomalies, subtle as they are, carry consequences for worlds nearby? Mars, fragile and thin atmosphered, may offer a prelude to lessons we have yet to learn about the cosmic environment we inhabit. As 3I-ATLAS drifts ever closer to Mars, it is not only a physical phenomenon that captures our attention, it is also a psychological one. Humans have long projected meaning onto the skies, transforming celestial anomalies into narratives that reflect our deepest hopes, fears, and collective consciousness. Each unexpected light, comet, or interstellar visitor becomes a mirror, revealing as much about us as it does about the cosmos. The Swiss psychologist Carl Jung described archetypes, universal symbols, and patterns embedded in the human psyche. The sky, with its vastness and unpredictability, has always been a canvas for these archetypes. The red glare of Mars evokes war, passion, or transformation. A comet streaking across the heavens may be interpreted as a harbinger, a messenger of change, or a cosmic punisher. ATLAS, anomalous in motion and accompanied by fragments, naturally evokes narratives of invasion, surveillance, or portent. In this sense, our anxiety is not irrational, it is archetypal, encoded over millennia of storytelling, observation, and myth-making. Collective projection extends beyond psychology into culture. In every society, unusual celestial events are recorded as omens. Babylonian scribes noted fiery guest stars, medieval chroniclers described red streaks across the sky, and indigenous peoples wove complex rituals around planetary alignments and cometary passages. These were not merely attempts to understand astronomy, they were strategies for coping with the unknown, creating meaning in a universe that otherwise appears indifferent. 3-1-ATLAS continues to evoke these impulses. A swarm of fragments, the subtle acceleration, the close approach to Mars, all are ripe for interpretation, narrative, and, in some cases, anxiety. The modern lens is no less susceptible. News reports, social media, and speculative documentaries amplify the sense of drama, framing Atlas as a mysterious intruder. Even scientists, trained to approach anomalies with data and calculation, cannot fully divorce themselves from the human tendency to narrativize. The very act of naming the object, ATLAS, imbues it with mythic resonance. Suddenly, it is no longer just a celestial body. It becomes a participant in a story that bridges millennia of human imagination. Jungian theory also suggests that anomalies trigger the shadow archetype, the projection of what we do not understand or fear. Interstellar objects, by their very nature, are strangers, intruders from beyond the familiar. Atlas is a reflection of our collective unease about unpredictability, fragility, and the limits of human control. The swarm of fragments amplifies this effect, as if the cosmos itself were teasing the boundaries of perception, challenging us to confront what lies beyond certainty. Yet, the mirror is not purely foreboding. Just as celestial anomalies inspire fear, they also spark wonder, curiosity, and creativity. The same streaking comet that incites dread can inspire poetry, art, and scientific inquiry. Humanity's engagement with Atlas through observation, calculation, and reflection demonstrates our capacity to respond to the unknown with both caution and fascination. Psychological projection, in this sense, is a tool as much as it is a mirror. It shapes how we interpret data, prioritize research, and imagine possibilities. The interplay between reality and perception is subtle but profound. ATLAS exists independently of our thoughts, yet our interpretation shapes how we experience it. A cluster of fragments may be entirely natural, yet in the human mind, it becomes a swarm, a deliberate formation, even a message. The thin boundary between empirical observation and mythic interpretation is precisely where imagination meets science, where wonder meets anxiety, and where history echoes into the present. This psychological lens also reminds us of the ethical and existential dimensions of cosmic observation. If our projections can inflate the significance of a natural phenomenon, how much more might they influence collective decisions, risk assessment, or planetary defense strategies? By understanding our tendency to mirror meaning onto anomalies, we gain a clearer perspective not only on Atlas, but on ourselves, on our biases, and on the stories we tell to navigate a universe that often feels indifferent. In the end, the psychological mirror reframes. 31ATLAS. It is no longer just an interstellar object approaching Mars. It is a catalyst for reflection, a symbol of the delicate interplay between reality and perception. The swarm, the acceleration, the anomalies, they are as much about human consciousness as they are about celestial mechanics. Through this lens, every observation becomes a conversation between the cosmos and the mind, between fact and myth, between awe and anxiety. And as we peer into the mirror of our own perception, the question arises, if the mind can shape the meaning of a passing star, what might our instruments, our machines, and even our civilizations inadvertently call forth from the depths of interstellar space? From Earth, we watch. Telescopes swivel, satellites orbit, and AI algorithms sift through streams of data, tracking 3I Atlas as it nears Mars. Every photon, every slight deviation in trajectory is logged, analyzed, and interpreted. Yet despite the sophistication of our tools, there is a profound limitation. We can observe, but we cannot touch, cannot interact, and often cannot fully comprehend what approaches. The universe remains distant, even as we strain to measure it. Space surveillance has evolved dramatically over the past century. In the early days, astronomers relied on long nights of painstaking visual observation, charting stars and noting anomalies with quills and paper. Today, arrays of digital telescopes scan the heavens continuously, using machine learning to detect patterns invisible to the human eye. Atlas was identified in part because of these automated systems, which parsed billions of points of light to recognize motion, speed, and luminosity. The advantage is clear. We can detect objects that would have gone unnoticed a decade ago. The drawback is equally stark. Detection does not equal understanding. Even the most advanced instruments face constraints. Atlas is distant, small, and reflective in ways that make conventional analysis difficult. Its trailing fragments, whether debris, natural companions, or something stranger, are minute, yet they shift the narrative. Each fragment must be accounted for, modeled, and projected, but uncertainty remains. Small errors in measurement can cascade, altering our understanding of trajectories and potential interactions with Mars. Observation without interaction leaves us perpetually guessing, navigating probabilities rather than certainties. Artificial intelligence has become a crucial ally in this endeavor. Machine learning models digest massive datasets, identify anomalous behaviors, and even simulate potential futures. Yet AI is only as reliable as the data it receives. Unknown forces, unanticipated physics, or behaviors outside historical precedent can confound predictive models. ATLAS challenges our assumptions. Its acceleration, the coherence of its swarm, and its unexpected path strain the predictive capabilities of even the most advanced systems. The object is a reminder that observation is an act of humility. No matter how capable our machines, the cosmos retains the right to surprise. Planetary defense protocols, too, highlight this tension. Agencies like NASA and ESA have developed strategies to track potentially hazardous objects, calculate collision probabilities, and even design deflection missions. Yet Atlas is not merely a generic asteroid. It is an interstellar traveler, one whose characteristics may differ from any object we have previously cataloged. Its passage near Mars is both a test of our preparedness and a stark illustration of our limitations. We can model, predict, and plan, but we cannot yet intervene in real time or control the unknown. The psychological dimension is as significant as the scientific. Humans are conditioned to seek control, to reduce uncertainty. Observing without touch, however, forces us to confront our vulnerability. Atlas moves through our models and calculations with complete independence, a reminder that observation is not mastery. We are spectators in a vast cosmic theater, able to see but unable to manipulate, aware that the universe operates on scales, energies, and laws that exceed our immediate comprehension. Historically, moments like these have always captivated the human imagination. Comets were once regarded as omens, meteors as messages, and celestial anomalies as divine interventions. Today, the tools have changed, but the experience is not entirely different. We record, analyze, and theorize, yet the sense of awe and unease remains. Observing without touch is both a privilege and a challenge, offering insight while emphasizing the vast gulf between knowledge and control. In this context, Atlas' approach to Mars becomes more than a scientific observation. It is a meditation on limitation. The swarm, the anomalous acceleration, the subtle deviations, all these factors underscore our dependence on indirect understanding. We interpret light in motion, model trajectories, and run simulations, yet the object itself remains silent, indifferent, unknowable, except through the signatures it leaves behind. Observation without touch is a paradox. We gain knowledge, yet we are reminded of how little we truly possess. Ultimately, this chapter of human engagement with the cosmos is a lesson in patience, humility, and vigilance. We watch, we calculate, we wonder, but we also accept the inherent limits of our reach. Atlas is not just a subject of study. It is a mirror reflecting the boundaries of human capability. In observing without touch, we confront the delicate balance between curiosity and caution, knowledge and uncertainty, and the vastness of space and the fragility of perception. And yet, even as we gaze and measure, a question lingers in the shadows. what if observation alone is not enough? What if the approach of Atlas and its swarm carries consequences that demand action, insight, and perhaps a reckoning with the limits of human foresight? The universe is vast, ancient, and as far as we can tell, mostly silent. For decades, scientists and philosophers have pondered Fermi's paradox. If intelligent life is statistically likely, why have we not yet observed it? One proposed answer is the concept of the Great Filter, a set of existential barriers that prevent civilizations from enduring long enough to communicate, colonize, or fully explore the stars. Atlas, with its anomalous behavior and accompanying swarm, forces us to reconsider what such barriers might entail. Perhaps interstellar objects are not merely debris from distant stars, but elements in a cosmic trial. The Great Filter could manifest not only as environmental challenges, self-destruction, or resource depletion, but as natural or even engineered interstellar hazards. Atlas may be entirely indifferent to life on Earth and Mars, yet its passage is a stark reminder that survival is contingent upon vigilance, foresight, and the ability to interpret subtle signals in the dark. The cosmos is impartial, yet every civilization must navigate its threats or risk erasure. Historically, humans have faced our own small-scale filters. Asteroid impacts, ice ages, pandemics, these events have shaped the trajectory of life, sometimes decimating populations, other times catalyzing evolution. The extinction of the dinosaurs, the upheavals of the Younger Dryas, and the scars left by near-Earth objects all testify to the fragile balance of existence. In each case, survival demanded awareness and adaptation. ATLAS serves as a modern reminder the universe still holds unknown tests, waiting silently beyond our immediate perception. Speculation enters the frame as well. Could interstellar visitors be markers of the Great Filter itself? Some theorists have suggested that civilizations capable of producing detectable signals might inadvertently attract attention, drawing the gaze of natural or artificial interstellar sentinels. Atlas' peculiar swarm and unusual acceleration hint at patterns that defy casual explanation, prompting us to ask uncomfortable questions. Is the universe merely indifferent, or are we being subtly measured? The line between science and speculation blurs, yet it is precisely in that tension that human inquiry thrives. Psychologically, the notion of the Great Filter is both humbling and sobering. It forces us to recognize that intelligence and technology alone do not guarantee longevity. The survival of a civilization may depend on observation, preparation, and the capacity to interpret subtle cosmic cues. Atlas becomes a living illustration of this principle, a reminder that being aware is not enough. We must act, adapt, and anticipate. The swarm of fragments trailing the main body underscores the unpredictability inherent in the cosmos, revealing how even minor events can have cascading consequences. Moreover, the Great Filter casts a reflective shadow on human ambition. As we look outward toward Mars, Venus, and the exoplanets beyond, we must also look inward at our own vulnerabilities. Environmental fragility, geopolitical instability, and technological hubris are all terrestrial echoes of the universal challenge. Civilizations must navigate their surroundings wisely or risk extinction. The universe does not differentiate between a thriving society and a fragile one. It simply persists, offering opportunity and peril in equal measure. ATLAS, in this context, is more than an astronomical curiosity. It is a narrative catalyst. Its approach forces us to confront questions that extend beyond orbital mechanics. Are there natural mechanisms that test civilizations? Are interstellar visitors mere happenstance? Or could their passage serve as a reminder that survival is neither guaranteed nor trivial? The Great Filter may be encoded in the laws of physics themselves, in the choreography of gravity and radiation, or in the subtle interactions of cosmic debris with fragile planetary systems. As the object closes in on Mars, our perspective must expand. Observation alone is insufficient. Reflection, preparation, and adaptability are essential. Atlas, with its anomalies, reminds us that the Great Filter is not an abstract concept. It is a lived challenge, a presence in the heavens that asks whether we are ready to endure. Every small miscalculation, every overlooked fragment, every underestimated force is a test of resilience. In this sense, the universe does not need to act deliberately to filter life. The filter is inherent, arising from the interplay of chance, physics, and survival. Ultimately, revisiting the Great Filter through the lens of Atlas is both humbling and enlightening. It reframes our cosmic context. We are not merely spectators, but participants in a grand experiment of endurance. Interstellar visitors, anomalous trajectories, and fragment swarms are reminders that awareness, curiosity, and prudence are essential. Survival is contingent, and perhaps, in observing and understanding these celestial phenomena, we are taking our first steps toward passing the filter. And as we contemplate the silent trials the universe may set before us, another question emerges. If the cosmos tests civilizations through subtle, unpredictable forces, how might our vigilance, or lack thereof, shape the fate of not just humanity, but life across the solar system? On a quiet evening in the late 19th century, astronomers peered through their telescopes, tracing familiar constellations and planetary orbits. Mars, usually a steady, ruddy point in the night sky, seemed different that night, an unusual crimson glow pulsing across its surface, almost as if the planet itself had ignited. Observers noted fleeting shadows, strange streaks of light, and a sudden ephemeral thickening of its atmosphere. The event was brief, leaving no trace for modern instruments to detect, yet it lingered in the meticulous journals of those who had seen it firsthand. At the time, explanations were scarce. Was it an atmospheric anomaly, a dust storm caught in an unexpected alignment with sunlight, or merely an optical illusion amplified by the primitive lenses of the era? Some whispered of cometary fragments passing too close, tiny interlopers brushing against the red planet and stirring its thin, delicate atmosphere. Others, more poetic in their interpretations, suggested Mars was signaling a celestial sigh, a warning, or a reminder of its distant, violent history. Today, we look back at that night with a different lens. With modern telescopes, space probes, and orbital spectrometers, we know Mars to be a dynamic world capable of sudden dust storms, atmospheric fluctuations, and even fleeting auroras. Yet the timing and the intensity of that historical glow hint at a pattern. The possibility that interstellar visitors, like 3I Atlas or its predecessors, may periodically interact with our neighboring planets in subtle, almost imperceptible ways. Could these transient events be echoes of passing objects, fragments, or cosmic debris that stir a planet's atmosphere long before detection is possible? The story of Mars turning red also highlights the human dimension of observation. Astronomers of that era were both scientists and storytellers, their notes blending meticulous measurement with personal interpretation. When they saw streaks or glows that defied expectation, their minds sought meaning. Were these phenomena random, or did they carry messages from the cosmos? In recounting their observations, they created a record that transcends raw data, bridging science and myth. It reminds us that human perception itself is part of the cosmic narrative, our fascination and anxiety written into the sky we strive to understand. Moreover, the event speaks to the cyclical nature of celestial interactions. Interstellar objects are not static. They traverse vast distances, returning in patterns too slow for a single lifetime to track. Each passing body carries the potential to awaken atmospheric reactions, magnetic disturbances, or optical anomalies on planets they approach. The night Mars turned red may have been a subtle reminder of this cosmic choreography, a whisper of objects like Atlas moving unseen, yet leaving traces in light, dust, or electromagnetic pulses. Speculative, yes, but the lesson remains. Planets are not isolated, immutable spheres. Their surfaces and skies respond to forces both near and far, natural and possibly deliberate. What struck Mars in 19th century observations may have been entirely coincidental, yet the alignment of its red glow with celestial phenomena invites reflection. Every unusual atmospheric disturbance, every brief flare or shadow, is a signal that the universe is alive with motion, interaction, and perhaps even intention. As we fast forward to today, with 3I Atlas closing in on Mars, the historical story takes on new resonance. Modern instruments record more than color changes. We measure acceleration, trajectory, swarm formation, and subtle radiation patterns. Yet the essence remains the same: a distant planet, a passing object, and the interplay of natural forces that stir wonder, unease, and speculation. The micro-story of Mars turning red reminds us that extraordinary events often go unnoticed, unconnected, until the universe gives us another chance to witness them. Finally, the tale leaves us with an enduring question: how many other red days went undocumented, unseen by human eyes, but recorded in the silent memory of planetary atmospheres? If 3I Atlas is capable of influencing Mars' environment even slightly, could the crimson glow of the past have been an early sign, an unnoticed whisper of interstellar visitors passing near, shaping the skies in ways we are only beginning to measure? And so, as we watch Atlas near Mars today, the echoes of past Martian mysteries remind us that the cosmos has long been capable of surprises. Each observation, each anomaly, is part of a pattern inviting us to ask, what subtle forces have brushed against our neighbors, unseen and unheeded, before we were ready to recognize them? The night sky is vast, and our gaze, though curious, is still limited. Each new object that drifts into the solar system challenges the boundaries of what we know and how we prepare. 3I Atlas, approaching Mars with anomalous speed and a trailing swarm of fragments, is a vivid reminder that the cosmos is not static, and that even a small miscalculation could ripple across planetary scales. Preparing for the unknown is no longer a thought exercise. It is an imperative. Humanity's first line of defense is observation. Space agencies around the globe maintain an ever-expanding network of telescopes, satellites, and sensors, scanning the heavens for objects that could pose a threat. AI algorithms sift through terabytes of data, identifying trajectories, velocities, and anomalies in real time. But the sheer volume of cosmic debris and the potential for unexpected behavior, like Atlas' sudden acceleration, means that even our best instruments cannot guarantee certainty. We can track, predict, and simulate, but the universe does not yield to certainty easily. Beyond observation, the planetary defense community has developed strategies to mitigate impacts. NASA's DART mission, which successfully altered the course of a small asteroid, demonstrated that humans can exert influence over celestial mechanics. Concepts like gravitational tractors, nuclear deflection, or kinetic impactors are no longer theoretical. They are tools we may one day deploy if an interstellar visitor crosses into dangerous proximity. Yet every plan carries assumptions, and the unpredictable behavior of objects, like a TLAs, reminds us that assumptions can be fragile. International collaboration is also essential. No single nation can defend the planet alone. Interstellar events are global by nature. Agreements on data sharing, emergency protocols, and rapid response systems are in place, but they rely on trust, coordination, and the political will to act decisively. History shows that crises often test human cooperation more than technical skill. When confronting an object that moves with mysterious acceleration and carries an enigmatic swarm, diplomacy and communication are as critical as rockets and radar. Yet even with all preparation, there is a profound vulnerability. Planetary defense assumes that we understand the forces at play. ATLAS challenges that assumption. Its unusual trajectory, the swarm of fragments, and the hints of acceleration beyond expected physics introduce uncertainty into every prediction. The unknown is no longer distant. It is measurable, yet defiant. In this context, preparation is not just a technical exercise, it is a psychological one, training humanity to live with calculated risk, to anticipate the unpredictable, and to remain vigilant without succumbing to fear. Speculative scenarios, while unsettling, can also guide practical planning. If Atlas were to fragment near Mars, could debris alter Martian dust storms or temporarily affect its thin atmosphere? Could a fragment redirected toward Earth or its moons generate localized but dangerous disturbances? Scientists run countless simulations, each revealing vulnerabilities and possible interventions. Preparation is iterative, adaptive, and deeply humbling, forcing us to acknowledge how small and contingent our existence is within the vast celestial arena. This readiness extends beyond rockets and sensors. It includes cultural, educational, and social dimensions. Public awareness, scientific literacy, and global communication ensure that when anomalies arise, societies can respond without panic. History has shown that misinterpretation of celestial events like comets or eclipses can lead to fear or misdirected action. In the modern era, we must balance wonder, vigilance, and rationality, recognizing that even as we reach outward with telescopes and spacecraft, we remain part of a fragile planetary ecosystem. At its core, preparing for the unknown is a meditation on humility. 31ATLAS reminds us that the universe operates on scales and with forces far beyond our daily experience. The object is not malicious, nor is it benevolent. It simply exists. Our challenge is to observe, interpret, and respond. Each new data point, every updated trajectory, and each fragment track adds a layer of understanding, yet simultaneously highlights how much remains uncertain. Ultimately, preparation is both hope and acknowledgement of vulnerability. It is hope because human ingenuity has already demonstrated that we can influence trajectories, detect threats, and collaborate across borders. It is vulnerability because the universe may present behaviors and events that defy even our most sophisticated models. Atlas, with its anomalous movement and approaching swarm, embodies that duality, a call to readiness, a test of resilience, and a reminder that the cosmos is alive with possibilities we are only beginning to comprehend. And as we plan, simulate, and watch, a deeper question emerges. How much of our preparation is for the known, and how much must we embrace the unpredictable? The universe does not pause for certainty, and as Atlas closes in, we are reminded that anticipation is both science and art. The vast expanse of space stretches endlessly beyond our comprehension, a theater where light, shadow, and gravity perform an eternal ballet. Against this backdrop, 3IATLAS glides closer to Mars, a silent intruder leaving scientists, philosophers, and dreamers alike suspended in awe. Its trajectory is charted, its velocity measured, yet with every new observation comes a lingering uncertainty. What is certain, it seems, is that the universe is far more complex and far more mysterious than our instruments alone can capture. As we watch Atlas approach, we are forced to reflect on our own role in this cosmic narrative. Are we merely observers, recording the universe's unfolding events with detached curiosity? Or are we participants, our technology, our signals, our gaze somehow entwined in the arrival of such objects? The possibility is both humbling and unsettling. In the history of human thought, the heavens have always mirrored our fears, ambitions, and collective imagination. ATLAS continues that dialogue a question without an immediate answer, a presence that challenges our understanding of cause and effect. Mars, bathed in faint sunlight, grows larger in our instruments with each passing day. Its red surface, long a symbol of war, mystery, and the unknown, now faces a visitor whose behavior defies easy categorization. And yet, for all our observations, we must accept that some elements remain beyond reach. The swarm that trails Atlas may be debris, or it may be something more, a natural consequence of interstellar dynamics, or a phenomenon that science has yet to explain. Either way, the approaching horizon is a reminder that the cosmos is not passive. It interacts, it surprises, and it challenges our assumptions about permanence, order, and control. History, too, whispers from the dark. Ancient civilizations recorded unusual lights in the sky, cometary visitors that seemed to presage both fortune and disaster. Some saw signs from gods, others warnings from the stars. Today, as Atlas nears Mars, those myths resonate with a strange modern clarity. Perhaps human observation, our telescopes, radio waves, and satellites is a continuation of that same ancient act, seeking understanding, seeking connection, perhaps even unintentionally calling forth events whose consequences we cannot yet perceive. Yet even as we contemplate causality, intention, or chance, there is room for wonder. The trajectories, the acceleration, the patterns in the swarm, these are not just data points. They are stories written in motion. They invite questions that cannot be answered definitively. Are we witnessing a natural anomaly or a sign? Are the laws of physics subtly bending in ways we have yet to grasp? And perhaps most profoundly, does our observation alone carry weight, shaping the unfolding of cosmic events? These questions linger, unresolved, echoing across the silent void between Earth and Mars. In observing, we are reminded of fragility. A single fragment, small yet fast, could alter the Martian environment, influence future exploration, or offer insights that challenge our assumptions about interstellar travel. On Earth, the stakes are similarly profound. Each discovery of objects like Atlas forces us to confront our vulnerability, our reliance on precise knowledge, and our capacity to respond to phenomena that arrive uninvited, yet undeniably present. The open horizon is both beautiful and dangerous, a stage for both contemplation and preparation. There is also a philosophical dimension. Humanity has long looked to the heavens for meaning through science, mythology, and art. Atlas' approach is an invitation to continue that tradition, blending empirical observation with existential reflection. In the quiet moments when telescopes are idle and calculations paused, we can imagine the broader narrative. Stars birthing worlds, objects wandering between systems and life on a small blue planet, striving to understand its place in the vast, indifferent cosmos. The open horizon is, in this sense, a mirror reflecting not just the motion of a distant object, but the motion of thought, curiosity, and awe within ourselves. Speculation inevitably follows. Could Atlas be part of a larger, unseen pattern? Might other interstellar travelers be on routes that will intersect with our solar system in decades or centuries? Could the swarm carry material that tells a story of another star, another planetary system, another civilization? Each possibility is a thread leading outward into questions we cannot yet answer. Each observation a spark of wonder that reminds us how much of the universe remains unexplored, unpredicted, and ultimately unknown. And so, as the TLAS closes in on Mars, we remain on the edge of discovery and uncertainty. Telescopes track, AI analyzes, and scientists calculate, yet the ultimate narrative is still unwritten. The cosmos is patient. It allows us to watch, to learn, and to speculate, yet it holds its full meaning just out of reach. The open horizon is not just a spatial concept, it is a temporal, psychological, and philosophical one. It reminds us that in every approach, every flyby, and every passing swarm, there is an opportunity to expand our understanding, and a reminder of how small and fleeting our presence is within the greater expanse of space. And finally, there is awe. The beauty of Mars against the black sky, the shimmering path of the TLAS, the delicate dance of its fragments. These are moments that connect human perception with cosmic motion. They are reminders that observation is a form of participation, that curiosity itself is a bridge between worlds. And as the object drifts closer carrying its mysteries, we are left with a profound open-ended question. In the theater of the cosmos, are we merely spectators, or have we, in our gaze and our technology, become participants in a story far larger than ourselves? The open horizon stretches infinitely, and 3i Atlas glides silently toward Mars, indifferent yet provocative. In its passage, we see reflection, fragility, and wonder reminders that the universe is alive with questions, and that the answers, if they exist, lie just beyond the edge of what we can see, measure, and understand.